Agents have human-like characteristics and capabilities, but they operate at machine speed and scale. Vijoy himself cannot do much damage in an hour, but a Vijoy operating at machine speed and scale can do a lot of damage.
Hi, welcome to AI Confidential, the podcast about AI and how to benefit from it responsibly. I'm Aaron Fulkerson, the CEO of Opaque.
And I'm Mark Hinkle, the publisher of the Artificially Intelligent Enterprise.
Mark, wonderful to see you as always. We just came off the Confidential Computing Summit. Why don't you kick off by sharing your thoughts on the event?
It was one of the best events I've attended in a number of years for a few reasons.
Is it because you were essential to it and helped organize the workshop on day zero?
No, that was hard work, man. I didn't get to kick back, but you guys did a great job being great hosts. The thing that I liked about it was that it felt sort of intimate and homey for something as, big and important as security and AI. I mean, it was some of the most impressive leaders, users of AI. And unlike something like one of the mega conferences, you actually could talk to the people you wanted to talk to. And it was interactive and collaborative. And those are the kind of events that I personally like to go to. So homey isn't the right word, but it was a community event with a very high stakes business objective. So I thought it was great.
Yeah, that's the intent of the summit, is that it's a gathering of really the most brilliant minds on the planet who are at the nexus of AI and I guess security. Really, it's more about trust, though. And that was the theme. In fact, I kicked this off in the keynote, this concept of the internet lacks a trust layer. In the first phase of the internet, that was human bound and rate limited based on physical limitations of humans, we could manage the gap, right? It's created some challenges with bad actors, but overall we could buffer out the bad actors. In this next phase, which our guest Vijoy Pandey will be talking about, it's an agentic web, and he summarizes it so elegantly with his statement about how agents have human-like capabilities but operate at machine speed, which I borrowed because we recorded this before Summit. I incorporated that statement into my keynote, and it became the refrain throughout all of Summit, that agents have human-like capabilities but operate at machine speed. They're self-replicating. We must build a trust layer into the network that is not just based off of legal or contractual or regulatory guarantees, because that's assurances, and assurances are hope. We're talking about having a verifiable, provable trust layer, which is what everybody at the summit has been building. And the nice thing to see was there were this year dozens of examples of confidential AI where you have these verifiable guarantees, and they each have their own different reference architecture. So as you cited, the collaborative nature of Summit was such that by the end of the event, you have all of the hardware innovators, NVIDIA, Intel, ARM, AMD, et cetera, combined with the hyperscalers, Microsoft, Google, Frontier Model Labs, Anthropic, DeepMind, et cetera, as well as enterprise deployers, Accenture, McKinsey. We all agreed that by next year, we must have interoperable reference architectures based off of like industry agentic workflows, agentic systems. So we're all committed to collaborating outside of the summit, but it began there. It began at Summit this year. And I'm just really proud of what we've already accomplished and how far the community's come. But you nailed it. It's an ecosystem that's highly collaborative because we understand what's at stake. Agency. So agency.org, it's spelled without the E. It's missing a vowel. It's something that's been pioneered as a foundation by Cisco Outshift, where Vijoy is the general manager and SVP, LangChain, and Galileo. And all three were at Summit. And of course, Atin, the CTO and co-founder of Galileo, is in a previous podcast. That's a perfect example of the importance of standards. I mean, Mark, you and I have talked about this many times. Every technology super cycle is fueled by open standards and open source, and we need a standard. Vijoy's been a pioneer at Cisco and Agency, and Opaque just announced at the event that we've joined Agency. They reached out to us, and we were very flattered and happy to join. Help them build the trust layer into that open stack.
So that's an interesting point about Agency is while Cisco took the lead on this, that it is more than just Cisco. It's an industry initiative. And I believe you made an announcement around it this week, and not just you, others. Can you talk a little bit about that, Aaron?
The Agency team reached out to Opaque about a month ago, and I had been tracking what they were doing, but they reached out about the need for a trust layer. So we were happy to jump in and join. We were so focused on getting organized for the summit. The catalyst of them reaching out was terrifically timed, because then we announced at Summit that we've joined Agency and we'll be working with them on building a trust layer. But to your point, there was a lot of announcements at Confidential Summit this year. AMD made product announcements around new hardware. Google made product announcements. Microsoft made product announcements. Anthropic made product announcements at Summit, which is just really rewarding. Like that they're coming to Confidential Computing Summit, the event that we organize, and they're dropping product announcements. And we had an incredible press lineup. We had New York Times, Wall Street Journal, Politico, Reuters, CNBC. It was an incredible lineup of journalists. Oh, Newstack, got to mention Newstack, our friends over there, that were all attending, including moderating panels in some cases. Like the fellow from New York Times was moderating a panel, and Frederick was not moderating from Newstack also.
Quality of attendees, the quality of folks covering it, the quality of the speakers were, it was a great week for me. I will tell you that I was exhausted afterwards, as I knew you were, because it was so much stuff, but it was the best, 3 days I've spent in a long time. Just learning.
9 out of 10. I gave it a 9 out of 10.
I give it a 10. Just like
right,
Billy
great.
Bob.
Good to hear.
Should we talk a little bit about AI in context?
Yeah, I think what we're going to start doing with these AI in context that you and I discussed at Summit is we're going to take a particular topic and we're going to focus on putting it in a broader context rather than talking about like the news, because things are constantly changing. Let's put a particular topic in context for the listener. So we're talking a lot about agents. Do you want to take a stab at putting that into a broader context for the listener?
Yeah, I think so. So, we're talking about agents, and the term that Vijoy that we're talking with today coined was Internet of Agents. And, there was Internet of Things, and that's sort of the riff there. But what does the Internet of Agents look like? It looks like a bunch of task workers that are able to interact, pass information back and forth through securely and using some set of credentials. They're very much like what the microservices pattern of the cloud was, where these discrete tasks are completed by, this is an algorithmically and somewhat autonomous microservice almost, but the pattern stands up. It's just that we may have workers that work for us as agents in our businesses, and we may hire agents from other businesses who are almost like contractors in the same sense. And for that to all work, we have to have a secure communication and identity layer so that they can, we can trust who we're working with. Just like you would have, a set of credentials for a contractor that you enlist to do various tasks within your business.
Yeah, that's super helpful, Mark. And let's deconstruct a singular agent. So a singular agent could be composed of a language model, large or small. It could be a collection of language models. Furthermore, I'll give you an example. I was on a call this morning with the head of AI for one of the world's largest financial institutions, and they were sharing how they were building agents using a combination of deterministic logic combined with machine learning models, and then also with large and small language models to identify signals, then ingest data, and then make decisions and execute tasks based off of the signal and the data. So that's a perfect example of an agent. So you can imagine simple agents like the ones that we've talked about, providing AI infrastructure for confidential agents that ServiceNow deployed, that allows their sales team ask questions about their compensation, which pulls data from a variety of different back office systems that's highly confidential and private. And they then get answers very quickly and are able to run routine tasks that previously would take 8 days to get a response from humans. Now they're able to get a response in 4 seconds. So from 8 days to 4 seconds, because they have an agent powered by confidential agents running on opaque.
Yeah. I mean, going back to this agent definition is the big difference that is not well articulated by our industry is the agent is autonomous and has the capability to do some decision making in the service of completing an objective versus, running a task that doesn't require, I might in the past have rotated a log or I would have sent an email. That's a task. An agent actually has some level of autonomy to decide if that task meets the criteria that I set apart from. Like, it might, in my example, it might send an email on my behalf, but it might analyze it for tone or based on the input, alter the message, where before it would have been just a template where it would send this automated stock message that never changes. So that's and then the key part that you're really bringing to the table with confidential computing, or as we're saying now, confidential AI, is the ability to do so in a secure manner the whole way through the process.
That's a great explanation, Mark. When you think about these individual agents, what we're seeing, and this is what Vijoy talks about, is that these agents get chained together into a system. They create a composite of agents or an agentic system. These would span customers and partners and suppliers and distributors. And then as these composite systems get combined, that's what Vijoy means by an internet of agents.
Yeah. So the thing that doesn't exist today is, while this technology to do the agentic processing exists, is that we still have some work to do on the protocols and the ability for these agents to interact. So I think that's the fascinating takeaway that I got from our conversation with Vijoy today, is that we're looking at what is that layer of the stack that enables the communication. What's the secure lines between various agents in the internet?
That's exactly the trust layer that we're talking about and was the focus for the summit.
Let's get into it with Vijoy. I think he's going to have a lot to share with our audience on how Cisco is trying to build the internet of agents.
Vijoy, it's wonderful to have you on the AI Confidential podcast with Mark and I today.
Pleasure to be here.
You're a senior vice president and general manager at Cisco, but you're also the head of Outshift. Can you start off by telling us the story of Outshift and giving us an introduction?
Absolutely. I mean, it's one of the most fun jobs I've had in my career, where you think of Outshift as an internal incubator at Cisco, and think of it as a whole host of startups that are trying to take Cisco into adjacent spaces. So if you think about Cisco's core businesses, you think about, of course, a networking giant. Security is a big play. Observability, especially after the Splunk acquisition, is a huge play. And collaboration is a big play as well through WebEx. And so when we think about Outshift, think about going into market spaces that are both space as well as time adjacent to those four spaces. So let me explain a little bit. So in terms of space, think of it as going after newer personas and their care-abouts. So if you're going after network engineers as a current persona or SecOps, what are the adjacent personas that we can build products for? So that's a space adjacent play. And then time adjacency is primarily around risk. So can we think about, even in those four pillars, technology that might be a little risky to get into, or markets where the tech has been proven out, but where markets might be still a little bit risky to get into. So we see ourselves in that case as being the ones that come in and reduce the risk for Cisco to get into a market. So an example of each one of those could be like tech risk could be quantum. So we are actually exploring quantum networking and quantum security. That's what we do at Outshift. And then in terms of market risk, I would say agentic, even though we still all believe in the tech and we believe the tech works, we're still trying to figure out what the market looks like. So that's what we do. We are structured, like I said, like startups, where we have everything from product and engineering to customer success and biz dev. Because as you enter these new spaces, you're not just dealing with building the product, which is actually more or less the easy part. It's the go-to-market machinery that becomes the difficult part.
Cisco was pretty famous under John Chambers for the spin out and the spin in. I can think of like Infamy with was it Mario Mazzella was the leader of that group, and a couple others I think he did. Is this different in the fact that it's insulated but not spun out?
Yeah, so I think Cisco has been a pioneer when it comes to figuring out incubation mechanisms within large organizations. And yes, the spin outs used to be the process in Chambers days. I wasn't around in Cisco then, but I know of them. They've been pretty famous from what they've done. But I think what Cisco has done over time is played around with that model, because that model had some drawbacks. There was this whole notion of alpha projects that Cisco tried out for a while. That was very product centric, but it was light on the go-to-market side. So that had some drawbacks. And so Outshift and this model, I would say, is another incarnation where we are actually taking the learnings from all of those. And in fact, like myself and a bunch of my leadership team have come in from other places. So I was at Google prior to this, and we had Area 120 at Google. So we've all brought in our learnings from all of these places as well as Cisco, and we've actually picked the best out of all of those worlds. We ourselves have been iterating over the past 4-5 years on what works. So
Yeah.
It's always a learning exercise, Mark.
Yeah. That's great.
One of the areas that you mentioned as a focus area for Outshift is agents. And you guys have launched an organization or a foundation called AGNTCY. I was thrilled when the team reached out to Opaque to join AGNTCY. Could you share your vision and mission behind AGNTCY?
Yeah, I mean, first of all, we are thrilled to have you on board and Opaque on board, Aaron. Uh, One of the big thesis behind AGNTCY is this belief that we need an open, interoperable internet for agent-to-agent communication. And the reason that belief comes about, and we've been thinking about this for almost 2 years now, and this came about through a paper, actually, and the work of Eric Brynjolfsson. He's an economist. He was at Stanford and at MIT. He talks about how you need a team of subject matter experts, especially in the AI agentic world. These will be specific agents that are subject matter expert agents. And you need a team of these agents to come together to solve for a larger business outcome. And you cannot think of business outcomes in an agentic world at a job level and assume that a singular agent can solve for it. And that was the initial thesis. And then people like Andrew Ng took that and ran with it and showed that this was really accurate in the code development pipeline, where if you remember some of the work that Andrew did almost like 18 months ago, he talked about a one-shot generation of code versus, even with the latest models, versus having agents that did code generation, syntactic checking, security checking, scale checking, and these all separate agents, even with older generation LLMs. And the latter actually performed way better than a one shot from a singular LLM. And so when these things were happening, we said, what this is speaking to is we need a collaboration platform for all of these SMEs to come together and solve for a business need. And in my head, the analogy that I had was like, this is like the movie making process, right? So if you think about a movie, you need a director, you need producer, you need a bunch of actors, screenwriters, and so on. They all need to come together, they work on this movie, and then they disband and do something else. But they need that collaboration platform. So that's was the basis behind it. And believe it or not, like within a couple of months, we were facing that problem within Cisco where we were getting all of these pitches from a bunch of these SaaS vendors out there who are like, we are all moving towards an agentic world. Here's how it'll help you, Cisco, and this is internal Cisco, IT. Here's how it's going to help you, Cisco, in your day-to-day. And that entire problem statement actually came home to roost. And we said, we need to do this. And so what we said is like, this is great. We need this collaboration platform. It is the Internet of Agents. We need an Internet of Agents to connect all of these things together. But to make it open and interoperable in the 21st century, in the 2020s, it's not the ITF standards that we need to look at. We need to look at open source. And so Agency was formed as the open source version of Internet of Agents so that we can drive that open interoperable thesis that we had.
I'm glad you bring up the Internet of Agents, which you're credited with coining. Tell us more. You just talked around it, so we have a pretty good conception of what you mean by that. But would you give us a definition of what you mean by Internet of Agents, what it looks like today, where we're going in the future?
Yeah, I mean, I think the basic premise here is, if you think about agents have human-like characteristics and capabilities, but they operate at machine speed and scale, which makes them truly unique. And what we are seeing is a transition. Because of this, we are seeing a transition from deterministic computing, which is like, I know which API I'm poking and I know exactly what I'm going to get. So I know the deterministic intent I'm sending and I know the deterministic outcome that I'm going to get. We're moving from that to probabilistic computing, where intent is probabilistic, outcomes are probabilistic. And that's because you have these things that have human-like behavior. Humans are probabilistic in nature, but they're operating at machine speed and scale. And we have not seen that happen in the past. And so when we move from deterministic to probabilistic computing at machine speed and scale, we need a collaboration platform for all of these things to come together, because as much as any one of us would like, all of these agents are going to come from different vendors. They would have used different frameworks to build those agents. They might be sitting on different clouds. They might have different identity requirements, not just when they were built, when they were acquired, but also the teams that are using them. They might be running on different clouds. They might take on different personas. They might take on different profiles based on the task at hand. So the heterogeneity is not just confined to software and machine. It's confined to persona, team, data that you feed into these agents. So that heterogeneity is actually exponentially more complex. But we are expecting them to collaborate together and solve for a business outcome. So that's the problem statement that we started out to solve through Internet of Agents. And what we said is, going back to the movie example, to solve for this, it's not a one-shot approach. And I know people are all consumed by protocols here, but let me just take a step back and say, It's a holistic approach because you need to first start with, so we break it down into 4 steps. You need to start with discovery. So just like the movie example, which agents do I really care about? What are their capabilities? Who's published them? Who's using them? Where? What personas are they taking on? So there's discovery. There's a discovery problem. There's a composability problem because you're bringing them together, stitching them together, either through a deterministic flow or in a self-composing manner. Then you deploy them, and you'll be deploying them on current cloud infrastructure or on-prem, doesn't matter. And then especially, as we talked about in the probabilistic sense, agents might promise you the world, but they might not deliver you the world. So how can you evaluate them and observe them to figure out whether they're actually doing what they're supposed to do accurately? And so that's the problem statement.
IBM came out with a proprietary one. MCP has sucked up all the oxygen from Anthropic. Google does A2A, and if we look back through history, is eventually it usually falls to the lowest common denominator of something that everybody agrees on. So that sort of today's technology may not be nearly as relevant, but I think it's interesting that you talk about discoverability, because as someone with a network heritage, SNMP, like we used to have to scan our networks to decide what was on the network. Now we're going to have these smart entities that are autonomous to some degree, and we've got to discover, are they good actors, bad actors? Are they, even, or neutral? I guess they're all neutral. It's just a matter of like, what are their capabilities? And then having a way for us to authenticate so that we know that the Vijoy Cabernet evaluation agent is, as good as the Mark Hinkle, bourbon evaluation agent, and are they both good judges of that particular spirit?
Yeah, I mean, if you see the Vijoy agent suddenly drinking white wine,
we'll know it's a Russian, it's of Russian descent, and it's infiltrating our network.
So that's something I was actually going to touch upon on the discovery side. But before I go into it, let me restate the 4 steps that you mentioned. 1, discovery. 2, composability. How do you orchestrate these? I assume, like how do you fit this together into an agentic system instead of individual agents? I presume that's what you mean. 3, deploy. Like, what's the runtime look like? Where does it deploy? 4, evaluation. On the topic of discovery, Mark went exactly where my head goes from my seat at Opaque, which actually has an opinion on each one of these stages. But on the topic of discovery, there's going to be this internet of agents, a federation of agents out there. We see today customers who are deploying their own discrete agentic workflows to solve a specific problem. Oftentimes it's based on RAG. Where we're going is they'll stitch together these discrete agentic workflows into a federation of these agentic workflows, and they'll compose them. How do you do the discovery on that, and how do you provide verifiability about the parameters of a prospective agent or agentic workflow that you're federating? For example, what if it is a Vijoy Russian bot agent that's infiltrating your organization, and you're going to interoperate with it via a Slack channel, and you think it's one of your virtual employees that's been issued company hardware, but in fact it's, some malicious agent that's egressing your intellectual property.
Yeah, I mean, you've covered a whole bunch of problems in the discovery phase, which are actually pretty interesting. And let me just try and walk through some of them. I think so Mark, where you were headed earlier with the SNMP, I would say the better analogy there is DNS. And so if you think about discoverability, here's a website. Which IP does it point to? Is exactly step 1, even in the agentic world, where how do I even discover? So where is this where can I get this capability? And so help point me to the right place for this agentic capability. Now, the complexity in the agentic world is that that right place could be a piece of code in a Git repo, or it could be a service endpoint being provided by someone. And I might consume it in both ways. So I might just suck in the code and build my agent, or I might just pull in the endpoint and use it in the workflow in the composability side of the house. So that's one, right? So just the incarnation, the instantiation. The second thing is like we're not just talking about an endpoint, we're talking about the capabilities. And we were just talking about these things where it's don't just give me a pointer, tell me what it can do. And how is it being, and what it can do and how it's being utilized is a multifaceted problem. Because as we discussed earlier, agents are not just static pieces of code, they're evolving. And they take on the persona that they're being instantiated within. They're sucking up data through RAG pipelines, and that changes their personality and the outcomes. So if you think about an agent, it's the software, the vendor who's created it, the enterprise that's bought it, but also the teams that are using it, where it's being instantiated, what data you're feeding into it. All of that should feed into what this agent is. And so there is a massive identity problem here as well, where there is an agent identity, a creator identity, and instantiation identity, because instantiation of the same agent in Mark's organization, Aaron's organization, and my organization will differ. And so there are all of these things. And to your point, Aaron, underlying all of this is let's hope, or let's make sure rather, that wherever this is being hosted is not compromisable. And so the trusted computing aspects, I mean, you rightfully said, Aaron, the reason why we're excited for Opaque to join this is the trusted computing aspects of this problem statement actually are pervasive across all of those four stages. Because if you compromise the directory, game over. If you compromise the identity, game over. So I think the directory and the discoverability problem is actually a pretty complex problem, and we are looking after it one by one. And I think this is one place to just point out that when we started looking at the Internet of Agents problems and agency as the open source incarnation, one thing that we were pretty clear about, and we still are, is that every time we push an idea or a code or a service, we ask ourselves 20 times whether this thing can be solved by something that exists today. And only push things, not just because it's shiny and new and is agentic. We are not just doing agent washing. We are only pushing the deltas that make sense. And so when we thought about the discovery problem, everything that is just discussed is actually net new. And one additional thing is, which we didn't touch upon, is we're talking agent to agent, but Mark, I know you mentioned MCP. There's agent to tool and agent to data sources. MCP servers are cropping up everywhere. And that discoverability and security problem behind that is another massive problem to solve. So it's a huge problem. We need a kumbaya moment here.
Yeah.
I mean, I think we cannot have 10 of these. Otherwise, Cisco would do what it does best. We will build a multi-protocol router.
Right.
I hope we don't get to that.
So I think that the one thing, and we talked about this, I think, with Joao from Crew AI the other week, is this idea of your identity passport, your tokens for agents, and all of that. I don't know. There were a couple of guys from Sneak that just started a company called keycard.sh, I think, that were, and they had written Passport.js, which one of them had. Like, is that how we are gonna? You think about how agents will have some kind of trusted credential, like, well, now DNS. Like we authenticate through all sorts of things by putting a text record in our DNS. Is that sort of the same kind of thing that we would, do, and then have some kind of central trusted authority like internet to manage it? Or how would you think about it?
The way we are thinking about this is if you think about current auth mechanisms, they were not, again, built for agents uh, because they were either built for humans or they were built for machines. And so there are service-based identities, there are persona-based identities, there are timer or time-based, not identities, I would say authorization. Sorry. So there's timer-based authorization. But really, what we are all converging upon is that, I mean, Vijoy himself cannot do much damage in an hour, but a Vijoy operating at machine speed and scale can do a lot of damage within an hour. And so what we're, I think, all converging towards is task-based identities, authorization, sorry, where you give agents authorization to do a certain task, and then you go back to default. And I think that's something that is, so we just announced an identity solution in agency that actually is working towards this goal, which is going to give you agentic authorization on a task basis. And we support all the standard identity providers, Okta, Microsoft AD. We also Duo just launched, which is a homegrown MFA solution. So Duo also just launched an identity provider platform. And so we support Duo as well. But we also support, it's actually based on W3C distributed, decentralized identity mechanisms. So it's actually a decentralized identity platform that we pushed in agency, because we truly believe that if we are true to our words of Internet of Agents should be open and interoperable, we shouldn't have a singular entity control agentic identity, and it should truly be decentralized. And so we built this platform to be DID compliant.
Do you think that these agents will have some kind of, I guess maybe the closest I'm trying to go between like the proof of work in blockchain versus maybe like a unit test in software. Like if this agent, say I want to rent my Mark agent to taste the Vijoy wine and rate it, is there some kind of proof of work, unit test? Like how are we going to evaluate once, not only can we spin up, do a lot of damage, we can spin up agents pretty quickly. And there will be, just like regular task workers, there'll be, A players, B players, C players, and the guy or gal that you would never want to be the player. And how would you like evaluate the, when we start interacting, how their performance is?
So this is why when we started looking at agency and the Internet of Agents, we looked at it holistically in those 4 steps that we discussed. So the discovery, which I include identity there, but there's a big feedback loop to that from the evaluation phase. Because based on the evaluation phase and how these agents are performing at the task that they claim to do, there's a reputation angle that needs to flow back. And that needs to flow back into the authorization aspect of it, where should I, to your point, allow the Mark agent to actually even come and open my cellar?
Exactly.
Because this guy is only talking about bourbon, and
yeah, exactly. Exactly. Is just especially when agents have these large language models that have a wide berth of what they could do. Like what I think what you said was really telling in the fact that early on you realized that the discrete steps and agents that were just your movie analogy was spot on. Is you have a director, you have a dramatic lead, you have a producer, you have a camera person, you've got a sound person, and they're all specialists. And those agents, I think, you want the best specialist if you want the best product.
That's right. And you need the identity and evaluation and the composability all to tie together, because that's what you're trying to achieve in the end. Is like, my specialists come together in this tiger team and solve for the goal that I have.
The way I think about this identity and composability and runtime, like each one of those goes back to the need for folks to be able to do hardware attested verification of each resource. So this is conversations with Mark Rusinovich from Azure, Mark Papermaster from AMD, Jason Clinton from Anthropic on previous episodes. We talked through this. The angle from Mark Rusinovich and Papermaster was, hey, it's always been a challenge that even in deterministic software, there's opportunities for people to slip in malicious code. And we can solve that through hardware attestation of software builds. We can also solve the potential for hardware backdoors through the manufacturing supply chain. If we do hardware attestation of the microchip design, then we can verify through the hardware attestation that this design is actually has integrity. We can do an integrity check on it. It becomes even more important in this new world, which I love your analogy of if a human can do very little damage inside of an hour, but a human an entity behaving as a human, potentially with hidden agendas, which we've talked about a bunch here too, is it's possible for people to infect a model with hidden agendas. Can do a whole lot of damage inside of an hour if it's operating at machine speed. Like, I love that analogy. So with this idea in mind, the concept of being able to do hardware attestation of a particular agent, that this is in fact developed by Anthropic. It has this version, it has these specific parameters. And then as you start to construct a system composed of multiple parts, which could be an agent, a tool, data connections also. Each one of these could have a hardware attestation that's verifiable of its integrity and policies that are explicitly defined, like for example, as part of a channel or a data connection. And then you're constructing from the ground up a zero trust chain of resources that you could expose over whatever that endpoint is. So you can start to federate these things together. And of course, then when you do that lookup as part of discovery, you have a signature that you can verify the integrity of in the specific parameters that's tamper-proof because it's signed by the hardware where it was originally compiled. And further, you can sign it at the instantiation as well. That's why, I think that's the future forward for us. And by the way, it's really interesting. I had not thought how uniquely suited Cisco is to tackling this agent problem, given its background in networking. Right? You guys are really uniquely suited to tackling it.
Yeah, and I mean, you're spot on, and the way you described it, I would say the only thing I would add to that is, and I think you were going there with the data part of it, is it's like humans operating at machine speed and scale, but also as they come across data sources, they're consuming this like Neo in the Matrix. I mean, it's like you're consuming all of this data, you're getting smarter as you, in this case, a malicious entity, as you cause damage. I mean, that's the full scale of the problem. It's like, yes, there's a malicious entity that behaves like a human. It's probabilistic in nature. It decides on the fly what to do. It's actually operating at machine speed and scale, so it's not slow as a human, but it's also consuming data and grasping it and making it internalized, and then taking decisions on that. So all of these data sources and pipelines are actually also at machine speed and scale. So yes, to hardware attestation on identity, on the directory, on the servers on which they're running on, whether they're on the cloud, whether they're on-prem, but also yes to the data sources, because even if you might sneak in attacks, and you're seeing this, a whole slew of attacks in the agentic world are just coming through like prompt injection and data poisoning and all of these attacks that are data-based. And they're not truly software or code-based. And so, yes, to the data side of it as well. And coming to the Cisco thing, I mean, the other big aha moment for us was the collaboration platform for agents coming together and talking to each other is based on communication and agents talking to each other. And when this thing started out, ChatGPT moment, a year later, agents, everybody was super enthused about NLP. And then you realize that, yes, a human talks to an agent through NLP, but agents can also talk to agents through an NLP. And humans and agents, we will all be in this kumbaya workflow through NLP. And you will deploy workflows where you'll have human in the loop and agent to agent all happening through a very probabilistic mechanism. And the way I think about this is, and for us network geeks, we can geek out for a second here, but the original internet, the transport layer was TCP/IP, and applications were built on TCP/IP. Every layer above that is gobbledygook. I mean, nobody really knew what a session layer did. I mean, it's like, okay, yeah, you broke it down into application, session, this, that. But it's truly, I mean, there's TCP/IP, there's BGP routing, and BGP wasn't routing. It was truly exchanging organizational policies between different organizations. And what do I allow from your organization and what can I ship to your organization? So both in and out. And so if you think of those constructs, when the cloud happened and mobile internet and the cloud happened and cloud native happened, that layer moved to HTTPS. And so suddenly HTTPS was the transport layer. Applications were sitting on gRPC, which is HTTPS. Routing was service directories in cloud organizations or service meshes within the organization. And all the applications, all your policies were sitting on that layer. With agents, we are looking at semantic communication now. And none of these layers are suited. So I believe, and this is my thesis, that we are going to have two additional layers above HTTPS. There's a semantic and a syntactic layer. Semantic is, what do you mean when you say X? So there could be a simple thing like, agent, give me the best X. And you're like, what is best? It's very probabilistic in nature. The agent comes back and says, here you go. This is the best X with 90% confidence. Is Mark's agent 90% confidence the same as Vijoy agent's 90% confidence? No. So there is a semantic layer, which is what do you mean? And then there's a syntactic layer, which is like, is the noun before the verb? Is the verb before the noun? And so in the context of agents, it's like, have you built all of this with LangChain, with Llama Index, with Crew AI? What is the framework that you're using? Are you on Bedrock? Are you on AI Studio from Google or Microsoft? I think these are the constructs. And then there's the meaning, which is like agent one talking to agent two. And what do you mean? So to us, that communication layer is actually so critical as Cisco to solve for, because like with everything else that we've talked about, that layer has ramifications to identity and discoverability, has ramifications to observability and evaluation, has ramifications to trust and guardrails. So all of those. So we are super, super stoked about that part of it, but also we are looking at observability, security, identity, wherever Cisco plays.
I think about, like, for years, we were always thinking about autonomous systems, like in systems management. That was the holy grail. And then Knight Capital lost $500 million in like 60 seconds or some crazy thing back in 2012. Is those two new layers, like, imagine we get to this point where we have a provisioning agent that buys stuff for our company, and we have the annoying robocall agents that are trying to sell to our provisioning agent. Do you think we block them at that level? Like, is there going to be some kind of control that says, you know what, I've disqualified this agent as a vendor, I've disqualified having a relationship? And I've been trying to think about it, like, I can like the analogies for like denial of service attacks and how we can like reject traffic. How will we are you thinking about how we, trust, but not just trust, but just block agents? Because, there will be bad actors that will just drive a lot of, junk into the the marketplace and the systems.
I have a very similar question I want to throw out there, just to add on to what Mark said. Do one of these layers need to be formally verifiable? Right? Do we need formal verification in these layers so that you have the ability to prove that the potential risk here is massive? It's potentially existential to the human race.
It's actually, you're not wrong, both of you. I mean, I think so. The way we look at this, Aaron and Mark, is these are the most interesting problems for us as an industry to solve. And so I'll throw you one aspect of this, which is in a utopian world, you trust humans to do this. What makes you trust humans? You trust humans because there are processes and guardrails and, again, identities and reputation and trust all attached to a human. So in some ways,
there's an implicit expectation that what's good for that human is good for all humans. A lot of the trust comes from that. And then a lot of the trust also comes from the statement you made earlier, which is, well, how much damage can one human really do?
Right.
And so here's the way I would answer this question, right? And it's a super interesting question. We're spending time on this like daily. The thing I would say is like, just think about the process guardrails, the security frameworks, everything that we've built for deterministic systems so far have to be rebuilt and reimagined for a probabilistic semantic layer.
I 100% agree with this sentiment.
And the formal verification I'll come to in a second, Aaron, because that's a super interesting question as well. But to me, we are starting at ground zero where we cannot even parse that semantic layer and understand what the KPIs are, what the verbs are that need to happen between two agents or n agents. So we need to start there because, again, that has ramifications to everything else. That has ramifications to what authorization I give an agent, for how much time, for what tasks, for what data access. It's like all of those things. So I think we need to start by even the parsing problem, but then we need to go through the equivalent of a firewall. And what does a firewall look like at this layer? All of the things that we've done for the deterministic layer need to be reinvented. On the formal stuff, I'll give you a little bit of a storyline. And I think, so this is in a prior job. So in my prior role, you can look at my LinkedIn, but I won't say where it was. We were trying to build formal systems for certain things. And what we realized is you need to first build out processes and guardrails that work to understand it well enough that you can then build a formal framework around it. Because right now, we don't even understand the semantic layer well enough that we can build a formal language to verify against. So I think the formal part of this, Aaron, is a little bit further out till we truly understand the guardrails, the frameworks, the silos that these things need to be put in as they interact and do their thing before we can start describing them in a formal language and then start verifying against that formal language. So I think it's still a little bit.
Yeah. And to be fair, we're asking you for the future of agents as it's being built. But I want to give, but it's interesting to understand the thought process, because I think it's such a foreign concept of, and you're great about saying it, the probabilistic versus deterministic. When I go and talk to people, and usually I'm talking to business leaders outside of tech, they like, I have to break it down. I'm like, this is the first time in a long that I can ever remember where we have massive probabilistic systems out there where person X and person Y can put the same input into whatever LLM and they're going to get a different output. I'm like, could you imagine if your calculator gave different outputs? That's what's happening with different stakes. Um, and speaking of calculators, every time I hear a term on this podcast in the background, I'm like, I wonder if that domain's taken. I would like to tell you that somebody owes you $200,000 because internetofagents.com is selling for $192,500 right now, Vijoy. So make sure you get paid on that.
I know, and I think yeah, I mean, we were pretty explicitly avoiding that domain because we want this to be a standard concept and term that everybody uses. It's not something that Cisco would want to own because it's a view of the world that we just want everybody to think about in those terms. Because the other alternative view is that you have siloed systems because you can solve all of these four problems of discovery, composability, deployment, and evaluation, and the identity and trust problems around it by saying, just come to my house and I'll make sure that you're well taken care of. And we are like, no, this is a town hall or a town square. I mean, we want everybody from all of these different houses coming together and talking about stuff. So it's not just my house. It's I can pick and choose maybe his house is not the right analogy, but I can pick and choose a hotel that I stay at, but I still want to be able to do the job that I want to do. And I think that's why we said this is more of a public statement. Yes, there'll be products that we are building. We're going to announce a bunch of these things as well over time. There are products that we are building that have net new capabilities around agency and the open source nature of it. But we want this thing to be as open and interoperable and not owned by Cisco as possible.
Yeah, nobody can own the internet. Nobody
That's right.
can own the internet of agents.
That's right.
Vint sort of talked about how the big areas he missed in designing the internet is an identity and trust model. Is it possible to have an identity and trust model at internet scale without without a formally verifiable system for that identity and trust model?
I think on the identity side, at least when the internet was found, we didn't have the whole DID and the decentralized identity frameworks. They didn't exist. And I think there's a lot of work that has been done in those spaces since. It remains to be seen, to your question, Aaron. I mean, I think even though there is a lot of work, especially on the consumer side, on this, on the enterprise side, it's still not gotten the traction that you would expect it to have. But our belief is like, if you go back to that thesis of agents are a good blend of humans and machines and software, we have a good chance of doing that because it's not just machines where you go to an identity provider that you love and trust, but it's pretty closed. And it's not humans where we are actually moving towards a more decentralized identity framework. I think if you blend the two, we do have a good chance. And one of the things that we're doing is we are launching an identity service based on this decentralized identity concept that actually allows for identity to be not controlled by a singular entity. And one of us had to take that step. And then we all need to make sure that everybody else is behind it. And so, Aaron, I think a lot of the work that Opaque does behind this is actually going to be super critical in how we make sure that that trust model is taken all the way down to the hardware layer. Because yes, we can do this in the open source or as a SaaS service, but how do we make sure that it's trusted all the way down? And so we need to talk through that and make that happen.
Yeah, and thank you for giving Opaque the shout out. That's very generous of you. But there's a lot of people who are building on confidential computing properties. Meta just in April released a paper on private processing with WhatsApp. They've got a great paper. They're speaking at the confidential computing, or they spoke because this will be out after a confidential computing summit. Meta, Apple, Microsoft, Google, they're all doing great work around taking properties of confidential computing to provide some verifiability, some provability. This identity that you're talking about, I'm excited to learn more about it. What are some agentic use cases that you're particularly excited about, Vijoy?
Yeah, actually, it's great to talk about some of these because we've been actually pushing a whole bunch of multi-agent workflows and use cases, both in the open source as well as products to our customers. And uh, it all boils down to, yeah, we've been geeking out on infrastructure all this time, but it's like the so what? It's like, yes, it's all fun and it's all great to build out these things, but why should I care? And one thing that I want to, even before I get into that, and I'd like to get your opinions as well, team, is I think it goes back to, I think, both Mark and Aaron, what you were phrasing earlier. There is a long term vision here, which is things are going to be pretty dynamic and agents are going to be acting like humans and at machine speed and scale. And how do you trust them? But we're not there yet. In fact, we're just starting out. And so it ties back to the use case question as well. How many enterprise grade multi agent or even singular agent, but multi agent workflows have we all seen? Very few, if any. And so we want to push that boundary as well. And so the one thing that we think about pretty often is it'll take time. And this goes back to the way we started, which is as Outshift, we look at technology risk, market risk. Agentic is in the market risk category because customers are still figuring this stuff out. And when you're figuring this stuff out, you don't trust it enough. There is enough belief in it. You want to do it. There's like everybody's asking for it. But you don't know what use cases make sense. You don't know how to build those use cases. And you don't trust it enough to deploy it at scale because you have not built them yet. And so one of the things that we're going to see is this natural progression from taking something which is very probabilistic in nature and taking that round peg and shoving it into a square hole, which is determinism. And then over time, realizing that we can shape that square hole to be more round in nature, which is probabilistic in nature, right? So you're going to see that transition in people's mindset where I'm going to take all of these probabilistic systems, but put it behind a deterministic workflow. Because guess what? In an enterprise, I can't deal with probabilistic outcomes.
I think you hit on time is something that, we always get excited about technology in the early days and overestimate it and underestimate it in long term is Ray Amar's law. But what people don't realize is today there is probabilistic in the enterprise and it's people, right? So we hire based on their resume, their experience, we train them, but most people, employees require, guidance and training, and then they have pretty good reasoning. Today, these agents, when I work with my clients, I'm like, it's going to take a while for you to train the agent. You got to transfer knowledge. And while you can go get knowledge transfer by buying a data set from the New York Times on history or something like that, it's hard to find the data set on a logistics manager that ships all the goods to Walmart. Like that needs to be trained. The second part that is, it's great because we see how fast it's going is just the reasoning capabilities. So that's why breaking it down into small discrete tasks works, is because technically these models reason, maybe with these, reasoning models, maybe they reason at the level of a 5-year-old or 6-year-old child versus, I do not want a 6-year-old to be making business decisions for my multi-million or multi-billion dollar business until they've gotten educated on it. I think that we're going to shrink that versus a human, but still today what we're limited by is really their reasoning capabilities and, the knowledge transfer for more of the specialized, things that are specific to certain companies and organizations.
Yeah, and I think, and it's all of the above, right? So it's the reasoning capabilities and the models, is the evaluation frameworks. How do you evaluate that 5-year-old or the new intern? and then make it get more reputable over time and all of the everything that we've talked about. But I think what's going to happen within enterprises is we're going to put all of these agents in very fixed workflows to begin with. And then over time, they'll become self-assembling and self-forming. And there's going to be a journey there. So I wanted to give this preamble because then I want to get into the use case question that you had, Aaron, where one of the use cases that we actually have in the open source is this agent called Jarvis. Now, everybody has an agent called Jarvis. So I'm going to ask the team to call it SRE Jarvis or Site Reliability Engineer Jarvis. But basically, it's a Jarvis for SRE use cases. And we started by building this out for Outshift. And so we said, you know what? We are a small agile team. We believe in this vision. Let's start with SREs and see whether we can automate. And that's the other thing. I mean, again, we can spend an hour on, which is automation is the first use case, but I don't think that should be the use case for agentic. But let's start with automation as the first use case for a multi-agent system. So SRE Jarvis actually is 20 plus agents tied together in various workflows. And it's got 50 plus tool and data calling backends. Again, they use agency components, it uses MCP, it uses everything out there in the open source. It has access to platform documentation, it has access to Kubernetes APIs, PagerDuty, AWS. It's got a bunch of agents that are looking at observability across identity. And we are tying all of these things together and we are building workflows around all things self-serve, which is how do I bootstrap a CI/CD pipeline for an application team? How do I give access to approved LLMs? How do I set up EC2 developer instances or a bunch of VMs or Docker images? All of these workflows, again, deterministic in nature, but these are 20 plus agents being tied up. And what we have seen is like we've gone from, and this is at Outshift scale, and now we're pushing it across a bunch of SRE teams in Cisco. 3 engineers that used to do this have gone to 0. It's like Jarvis only. So 3 SREs down to Jarvis. 30% of tasks today from 1 day to minutes. And that's just today's 30%. And the goal is to improve that over time. And then any type of questions you might have about why isn't this working or how do I do this? All that is Jarvis as well, which is like an hour maybe to seconds. So critical use cases, clear outcomes, and a complete multi-agent workflow. There's a community called CNOE or CANOE, which is a cloud native operators community. It has people from Adobe, AWS, Cisco's there. We are all contributing to this Jarvis, SRE Jarvis in the open source, but that's a clear use case. We're also building a bunch of use cases working with some of our service provider partners, where we are taking a look at the entire networking deployment and debugging workflow. So network config management, change management, validation of configs, debugging of issues, network digital twins, all of that in a multi-agent manner. And that we're going to talk about that in a couple of months as well. But these are some pretty concrete use cases that we've actually shipped. We are doing an agentic workflow for security. So we are seeing this happen. So it's not in the lab. It's both open source as well as product, but we are actually seeing this happen.
When you said SRE, I was like, this is what I wanted for years, but I'm like, you can cause a lot of damage. Do you find that a lot of them are, a lot of SRE is just doing root cause analysis, which is something that seems like a logical thing to offload to agents. Like where do humans fall into that loop? And do you have certain, risk reward metrics around which tasks that you've decided to do that with?
So it is pretty like simple tasks right now. So it's like setting up a CI/CD pipeline for a new application or setting up an EC2 instance. I mean, you should not need a human to do that. And so that's why I said it's 30% of tasks that the team does. But this goes also back to the deployment model. I mean, these are all very deterministic workflows. And then there's, like I said, the free for all self-forming, but there's one in between, which you touched upon, Mark, which we call the semantically routed. And so you have deterministic and then free for all. But in between, there is one where you say, I have multiple workflows, or in fact, the way you say it is like the graph can take many decisions at any node, and the human in the loop can decide which decision or which path to take in that deterministic graph. And we call that semantically routed because what you do there is the human in the loop, you need to parse that and figure out, really, did you mean I need to go here or I need to go there? And so that's a semantic routing that you need to do at every step. But that's where we are headed next. The free for all, I think, is a couple of years away.
Yeah. But that's actually a great use case, the self-service, because that has been the biggest blocker for productivity for as long as IT has been a part of my job, which is most of my career.
The statement you made about fitting a round peg into a square hole, a probabilistic system into a deterministic pattern, or at least probabilistic within acceptable boundaries, right? That's what we're talking about here. Is what you're doing is with Jarvis is like, okay, here's a subset of activities, and you're delivering probabilistic outcomes within an acceptable set of boundaries, even within that subset. And to your question earlier, like how many of these agentic systems are we actually seeing in enterprise? Opaque, we're doing this. It's a really elegant way of articulating what Opaque's doing and what we're seeing our customers and enterprises want, which is how do we fit this probabilistic into acceptable boundaries of probabilism, right? It's another one of your great points that I took a note about, right? You've got so many terrific insights you've shared here that have helped me frame my thinking and how I will present, whether it's Opaque or just in conversations with people around AI. And I really thank you for that, Vijoy. It was excellent talking to you.
Thank you, Aaron and Mark. And I think it's been a great conversation because you also challenged me to think about where things are headed, and I think this is where a community helps, where we all need to come together, and these are pretty vast and gnarly problems that we need to solve for a world that is going to be very, very different, because we have a new tool in the toolbox and we don't know really at this point how that tool is going to behave because we're not used to that tool. And so this probabilistic tool, we need to shape it, but we don't need to clamp it so hard that it becomes deterministic. And then you've lost the advantage of that tool. So I think that's a pretty fine balance that as an industry, as a community, we need to do. And thank you for all the questions.
Yeah, thanks for being here. This was a lot of fun.
One of the most fun I've had in a while.
This has been amazing.
Talking to Vijoy was a delight. Like genuinely, it was just thought provoking, and he's like one of those people that I could sit there and talk to for hours.
Yeah, and as big as this industry is, it is still very small in a lot of ways. I've known Vijoy for many years, and he was instrumental in a company I was working on in cloud. And that's the thing that struck me about him when I first met him, was he was very thoughtful, very good at articulating how these frontier capabilities in AI and AI networking and security and how they affect the everyday business. So that's, probably one of the the most enjoyable, thought-provoking conversations I've had in quite some time.
As Vijoy talks about in the pod, what is important to understand is just the amount of, I guess, damage, the amount of an agent with human-like capabilities operating at machine speed can cause tremendous damage within an hour. Whereas if it were a human or a group of bad actors over the course of months or a year, it's pretty limited what damage they can do. But when you take one of these agents that's self-replicating, that's a different story.
Yeah, I think the what is finally coming to bear is we used to have these ideas of autonomy that were more like a flow chart. And so high-speed trading had algorithms that they based on. And what we saw in the early days of this without having, and they had circuit breakers and things to stop things from going awry, but the circuit breakers were dumb. They're based on, if this, then that kind of logic. And the biggest story in probably the last 20 years was when Knight Capital had their high-speed trading platform, destroy $400 million worth of value in their portfolio in under a minute. And they didn't have the smart protocols in place that we could today. But, the protocols and the agents are only as good as their capabilities. And so we want to make sure the capabilities for this autonomy do not go so fast that a human can't, they have to be trusted enough so that they're going to be faster than any human, and that they're doing so on our behalf and not causing, damage in their ability to, automate so much of our work.
Yeah, and all of our current systems, which are hierarchical access control lists, or static policies, or paper-based governance programs that are post facto, clearly they cannot scale to this new kind of agentic web. And that's why there are mechanisms that, in fact, opaque, and in fact, Microsoft and Google and Meta and Apple, they all shared examples of their own confidential AI stacks that create verifiable guarantees around policies and restrictions, et cetera. So it's not a matter of assurances or legal contracts, which an agent doesn't understand a legal construct, right?
Right.
All of these current constructs are really based purely on hope, which is not an effective strategy in this world. Instead, there's ways to do provable, verifiable guarantees before, during, and after, with an audit trail that's signed as well. If you want to learn more about how to use AI responsibly, check out our website at opaque.co. If you like the podcast, please subscribe wherever you find finely made artisanal podcasts, and leave us a review. We'd love to get your feedback. This episode of AI Confidential was produced by Wolverton Media Solutions, Places Media, Kodiak's Media, the AIE.net, and Opaque, the leading confidential AI platform in this galaxy. Our music is from my buddy Matt Melamuka at Peakspan Ventures. I'm Aaron Fulkerson.
And I'm Mark Hinkle, the Chris Farley of AI, as my producer Mia likes to say. We'll see you next time, and keep in touch with me by subscribing at theaie.net. I was really impressed with the takes that Mark, the CTO for Microsoft Azure, had on Azure. I
like how you said Microsoft.
Microsoft
Azure, right?
Pork chops and applesauce. P-pop, is that like K-pop? Please do give us that thumbs up. Give us the 5 stars on your favorite platform. If you see Aaron Fulkerson in public, give that man a hug, because he does this all to keep you educated.
Please don't hug me.